So hi everybody, in today's video we will discuss about some of the physical applications in the syllabus of first order and first degree differential equations. So today's topic is to discuss about law of natural growth and decay that we will discuss today. So I will tell you one same formula for both the formulae. Let us discuss about that. So the rate of change in the amount of material at any instant of time is directly proportional to the amount present at that instant. So that is the formula. So naturally what will happen? So the rate of change in the amount of material is always directly proportional to the amount present at that instant. So this is the very important point. Suppose for example, if I take m represents the amount of material, then the rate of change in m is nothing but represented by dm by dt. Now we will see what is the differential equation governing this one. Okay, this formula we will see now. So if we will consider the amount of material is m, once again I am repeating, if m represents the amount of material, then the rate of change means dm by dt. It is always directly proportional to the amount present at that instant. In the sense, dm by dt is always proportional to m. Now here, this is the common formula. So in the sense, by this we will get dm by dt is equal to some km, where k is the nothing but the proportionality constant, which is always positive. Now here we have two different type of formulae. One is law of growth, another one is law of decay. Law of natural growth and law of natural decay. So means whenever we will discuss about the growth, so the material will increase. So that's why at that time we will get dm by dt is equal to km. We will get, in the case of decay, as the amount of material is decreasing, so we will get dm by dt is equal to minus km we get. So this negative sign indicates the decay in the amount of material, loss in the amount of material. So these are the two things. Just if we can remember, then we can easily solve the problems related to this. Okay, so growth means we will get positive and decay means we will get negative. So now this is the differentially first order and first degree differential equation governing the concept of law of growth or the decay. Growth means positive, decay means negative. Now we will try to solve this first order and first degree differential equation, and finally we will see what is the formula for this. So we will see the formula for growth. From the previous slide we got dm by dt is equal to km we got, where k is nothing but the proportionality constant. Now we will see how to solve this. Now it is nothing but a variable separable differential equation. So means now this one can be written as dm by dt is equal to km we have. Now we will solve this. Dm by m is equal to, of course k is a constant, we can write it as dt. Now we just integrate this on both sides, then we will get integral of dm by m is equal to, k is a constant, k into integral of dt we get. So if we integrate this, integral of dm by m means we will get log of m is equal to k into integral dt means t we will get, plus the c is an arbitrary constant, or the otherwise the integral constant we will get. Now we will simplify more. So that implies we get m is equal to, by applying the basic logarithmic formula, we will get m is equal to e power of kt plus c we get. Otherwise you can write this one as e power c into e power kt, we can write it. So e power c can be written as some c1 into e power kt, we can write it as c's. So this c1 is nothing but e power c. So finally we can write, in generally we can write the formula as m is equal to some c into e power kt. So this is the formula for law of natural growth. The same if you perform for the law of decay, then we will get the formula as m is equal to c into e power minus kt we get. That is the only difference. So this is for law of decay, natural law of decay, and this is for law of growth. Okay, now we will see some problems. First of all, we will see some problems related to this growth and all. So this is the problem. So the number n of bacteria in a culture grew at a rate proportional to n. The value of n was initially 100 and increased to 332 in 1 hour. So what would be the value of n after 1.5 hours? In the sense here about some bacteria is the problem is related to bacteria. So bacteria in a culture is growing at a rate proportional to n, and it was given that n was initially 100 and increased to 332 in 1 hour, and we have to find out the value of n, in the sense the number of bacteria after 1.5 hours. So initially 100 and increased to 332 in 1 hour, and we have to find out how much will be there at the end of 1.5 hour, that we have to calculate. So here obviously given that the number of bacteria is increasing in the culture, so therefore we have to use the law of natural growth, that we will see now how to evaluate or how to solve this problem. So by the law of natural growth, we have that m is equal to c into e power kt. So this is the formula. Now one by one here we will see. So here m means, we will discuss about all the variables first of all. So m means amount of material, here means here it is nothing but the bacteria, means that is here it is nothing but the amount of bacteria here. Here it is amount of bacteria. Okay, next C, the arbitrary constant, and next variable we have K. K is the proportionality constant, and then we have T, the time. Okay, so here these are the two constants which we have to calculate. First of all, basing on that one only, depending on the problem, the requirement, we can calculate either m or t. Okay, so means we will try to solve this problem in 3 steps. Step 1, we to find the C value. So in generally we can find out the value of an arbitrary constant by using the initial condition. So initial condition means the initial amount of bacteria, how much is there, basing on that we will find out. So it was given that initial amount of bacteria is 100. Initial amount of bacteria in the sense, so given that initial amount of bacteria is 100, in the sense at a time t is equal to 0, n is given as 100. So means initial amount of bacteria is given as 100. Initial means at time t is equal to 0. The number of bacteria in the culture is given as 100. Now by using this, we can find out the value of C, and we will see. Just you substitute these two things. Just you take this one as some equation 2 and the formula is equation 1. Now we will substitute this 2 in 1. Therefore, by substituting the details in equation 2 in equation 1, we get, so m value is given as 100. It is nothing but the amount of bacteria. Okay, if you have any doubt here, you can write that is nothing but n here, amount of bacteria is n. N is equal to C into e power k into t, as initial time is 0, here we have. Okay, means by this if you observe, where simple simplification here, we will get C value as 100. Now you just substitute this C value here in the formula, then we will get m is equal to C means 100 into e power kt. This you may take it as some equation 3. So in step 1, we have calculated the value of the arbitrary constant C, and by using the initial condition we found it and we got it as 100, and just you substitute that one in the formula, then we got the formula is now transforms to m is equal to 100 into e power kt. Now we will go for step 2. In step 2, we find the value of K. So for that one condition is given. The value of n was increased from 100 to 332 in 1 hour. So means after 1 hour, means at t is equal to 1, in the sense 1 hour here, at t is equal to 1 hour, n value is given as 332. So by using this condition, we can find out the value of the proportionality constant K. And suppose you take these details as some equation 4 and just you will substitute. By substituting the details in equation 4, in equation 3, we get, so m value is m is equal to n, it is nothing but 332. 332 is equal to 100 into e power k into t value is given as 1. So e power k means, from this we can conclude that e power k is equal to 332 by 100, or otherwise k is equal to log of 332 by 100. This is the k value that what we get. Now we just keep it aside. Now we have the k value and c value. Now we got to both the two unknowns. Now we find, in step 1 we find c value, in step 2 we got the k value. Now the final problem what we have to conclude is, after 1.5 hours how much amount of bacteria will be there. So that is our last step that we will calculate now. That you can take it as step 3. So in step 3 what we have to find, how much of bacteria will be there at the end of 1.5 hours. Means we have to find out n at t is equal to 1.5 hours. So this is our target now. So again we will apply this equation 2 by using, equation 3 we will have here m is equal to 100 into e power kt. We will apply this formula now. So we have to calculate m now. So m is equal to 100 into e power k into t, means t is given as 1.5, t is given as 1 by 2, in the sense we can write it as 3 by 2. Okay, means 3 by 2, k into 3 by 2 here we have. So that is equal to 100 into e power 3 by 2 into. So here already we have the k value. It is nothing but k is equal to log of 332 by 100 we have. So you can write it as e power log of 332 by 100 we can write it. And if we simplify this 100 into e power of log of 332 by 100 whole power 3 by 2 we'll get. In the sense 100 into, so e power log of means by simplifying this by using the basic logarithmic definitions we can write it as 332 by 100 whole power 3 by 2, and here by simplifying this nearly we can get 604.9 something we'll get. So nearly we can write it as 605. So means after 1.5 hours the amount of bacteria present in this culture is nothing but 605. So once again I will repeat. So the number of bacteria in a culture was initially 100 and increased it to 332 in 1 hour, and after 1.5 hour what will be the amount of material or amount of bacteria present in that culture. So as the amount of bacteria is increasing, so that's why here I have taken the formula of law of natural growth, and it is m is equal to c into e power kt. Okay, and we will do this problem in 3 steps. In step 1 we will calculate the value of the arbitrary constant c by using the initial condition. Next, after one condition is given, how the number of bacteria is increasing, it is given as in 1 hour it is increased to 332. So in step 2 by using that condition we will find the value of the proportionality constant k. So in almost all the problems, 99% of the problems, we can divide the total solution in 3 stages: step 1, step 2, step 3. In step 1 we will find the arbitrary constant value, in step 2 we will find the proportionality constant value, and in step 3 whatever may be the required, whether it is the time t or otherwise the amount of bacteria or whatever it may be, amount of material we need, that according to that we can find out that one in step 3. So this is how we can solve the problems in the law of natural growth. So thank you everyone.